Hello, everyone, and welcome to our event here today. My name is Ofer Mendelevitch, and I run developer relations for Vectara. And with me, I have uh, some very esteemed guests that will participate in our event today. I will start by letting each of them introduce themselves, and maybe we can start with Amr.
Yes, hi everybody. I'm founder for Vectara with Amin also with us here. I'm the CEO for the company, and previously I was also founder and CTO for Cloudera, which some of you might know.
Thank you, Amr. And Amin?
Yeah, hi, my name is Amin. As Amr mentioned, founder at Vectara, currently CTO. Previously, I was in Google Research for about 8 years.
Great. And Jay?
Hey everyone, I'm Jay. I'm part of the developer advocate team at Nvidia, and I specifically focus on large language models and to evangelize the best possible workflow and optimize all kinds of LLMs on Nvidia GPU.
Thank you. And Laurie?
Hi, everybody. I'm Laurie. I'm the head of developer relations at Llama Index, the framework for connecting your data to LLMs. And in a past life, I was the co-founder of NPM.
Wonderful. Thank you, everybody. And, to set the stage for what we're going to talk about, I'll give you a little bit of a personal story. I have been using LLMs for about 5 years, and I got introduced to the work of flash attention by Tree Dow and some of the folks at the lab in Stanford who started working on longer sequences. Sorry, and we have Hassan who's just joined us. Hassan, can you hear us?
Yes, I can.
All right, thanks, Hassan. Just in time. So we just finished our introductions. Do you mind doing your own introduction, please?
Yes, my name is Hassan. I do developer relations at Together.AI, and we're a generative AI company. We help people run inference on open source models and fine tune them and use GPUs.
Perfect, thank you. And so I was starting my kind of personal story around this, which will tie in, Hassan, with Together.AI. I got to know Tree Dow, which I believe is still your chief scientist, and others that he was working on at Stanford when they started the work of flash attention. The work of flash attention was really, in my mind, a pioneering work that allowed a lot of the longer sequences in LLMs that we have today. It started from when I started using LLMs, I think it was 512 was the sequences we had, and maybe 1,000 was like, wow, we doubled it by 2x. It was amazing. But I think there was a lot of work to try to lengthen that, and Tree and his colleagues at Stanford were, I think, instrumental to making that work. But now there's a lot more work that's been done by a lot of other people around the world and around different research labs in industry as well. And this really opens up this idea that now LLMs we have 100,000 tokens, 200,000 tokens, and even 1 million tokens in the latest Gemini model, which is incredible and opens up a lot of opportunities. And so really the topic of today's talk is related to RAG, or Retrieval Augmented Generation. And I'd like to discuss with you all how is that relation between retrieval augmented generation, where it is today, where it's going to be in the next 2, 3, 5 years, and how do long sequences impact that? I'll start with the most obvious kind of hot question that people ask is, well, if you have a longer sequence, will RAG die? And this is the title of our session today. Will it kill RAG? Couldn't you just stuff all the documents into the 1 million document length and you don't need RAG anymore, to be precise, right? So I'd love to hear from you all. What's your perspective on this? What do you think about that?
You want to pick somebody to go first?
Yes, I mean, why don't you start?
Yeah, so I think it's a good question, Ofer. And you said million documents, but I think it's more like a million tokens. And if you think about a million
And
tokens, I
tokens.
try to do some back of the envelope math. It's about 2,000 pages of text. Um, and I think there's an obvious point, which is many problems involve knowledge bases that are much larger than that. I mean, if you look at the average, corporate intranet, or if you look at a relational database, the amount of data is far exceeding a million tokens. But let me look at. There's several angles I can look at this question from, but I'll just start with one and then turn it over to the others here. Um, the question is, you have the longer context. That's great. That's very powerful. But how do you fill the context? So what you're implying, what you said there is, okay, the user who needs some information can take all the documents that they think are relevant and fit them in. If you've got about 2,000 pages or less, you can now put it into the context, and the LLM can basically analyze that and answer your question. That's a manual way to fill the context. Another way to fill the context involves an extra hop, which is that the user is articulating what question they're trying to answer. And now you have a computer system automatically filling up that context, potentially looking at a very large knowledge base of millions of documents, deciding what might be relevant, and filling the context. So the only thing that's changed here is the amount of context that you have available to fill. And what implication? So the retrieval layer is not going away. It's as important as before. If there's any change to the architecture of the retrieval layer, I think it's this. That retrievers in an IR pipeline generally tend to be more recall focused than precision focused. With the idea that later stages in the IR pipeline then focus on boosting precision, whether that's a re-ranker or that's an LLM. With the increase in context length, that just becomes even more true. The bias towards recall becomes even higher. So I'll stop there. That's an initial answer.
Jay, what do you think?
Sorry, I missed it. Was it me?
Any thoughts from you?
Your
Yeah,
thoughts on this issue?
yeah. I can go. So I agree with Amin here, and I think RAG RAG will still be here because it provides benefits such as accessing up-to-date information or improving the factual accuracy of the answer by sourcing the relevant document when the LLM answer is presented. So I think filling that long context, as Amin said, it's difficult. And I'd like to share a study that was done by Nvidia Research recently, where they tried to compare long context LLM versus retrieval. And what they found out was LLM with short context length. In this example, they took a 4K context length LLM performed better than a fine-tuned LLM having 16K of context length for long context tasks like summarization, question answering. So I think even if long context LLM can get in more data, but I think having LLMs with retrieval augmented generation will still perform better in terms of accuracy and with less compute needed as compared to the bigger ones. So yeah.
Anyone else have anything to add to that? Laurie, Hassan, Amr, what do you think?
Yeah, I think I'm mostly echoing what everybody else has said, but I like to imagine this sort of absurd case. What if we had an LLM that had infinite context window? What if there was no limit whatsoever? And in that situation, it would be the case that you could put all of your documents, literally all of your documents, into the context window every single time and try and answer the question. But if you had that power, you'd still know, well, this is a very expensive way of solving this problem because I have to, I'm paying by the token. And if I could only, narrow down the number of documents that I'm putting into this thing, that would be cheaper. And it would also be faster. So our position at Llama Index is that it doesn't matter how long the context window gets, doing RAG is always going to be cheaper and faster, simply because you're being more selective and you're being more accurate to start with.
Yeah, very good point. Very good point. The cost and the thing. Yeah, sorry, Amr, go ahead.
Yeah, I was going to say that I think that's really the gist of it. That is the summary. Like, it's relying on the context window. It's kind of like imagine if the LLM is a human being, right? Not imagine that for a second, as opposed to a neural network. And every time you're asking them to go research something, you're asking them go read all the books I just gave you again to answer it, and then read them again to answer it, and then read them again. So it's like I can imagine the LLM saying, "Why do you keep asking me to do all of this work? Can't you just give me highlight for me the 2-3 documents or the 2-3 paragraphs that are most relevant, as opposed to asking me to leverage all of my brain power to go through all of these documents and provide you with the answer." So I think that the summary is really, it's the cost, it's the latency, obviously, of going. You can see these larger context windows when you feed them bigger number of tokens in the input. They take forever to give you back generated text, so they're much slower. And then last but not least, the quality will not be as good. So there's many research and many investigations that show while the larger context window can do very well for finding a single needle, like a single piece of information that is relevant within the context, when you're talking about multi-needle, meaning there's more than one relevant pieces in there, keying off of different semantic meanings, they don't do very well, right? They start failing because there's so much they have to go through. So I think it's a no-brainer that for this kind of task, we will always benefit from having something ahead of the LLM that finds the most relevant needles in the haystack, and then tell the LLM, focus on these to give us the response, and it will give you a much higher quality response at a much higher speed at a much lower cost. I think that's my opinion. I'm biased, obviously, being at a RAG company, but I think that's how the future will unfold. I'm curious, Hassan, what do you think about this yourself?
Yeah, definitely. I mean, I echo, everything you guys are saying. Latency, cost, and accuracy are definitely really big. And I think like longer context windows are ultimately, I think, a good thing for everybody. Like that doesn't mean RAG is going away. It means you can source even more relevant documents or relevant contexts and get them in there. So yeah.
Exactly. Yeah, like we have been very focused on trying to get the few sentences that are relevant. Now we can feed a few documents that are relevant, right? And we can get a much higher quality response. And there is some use cases where that larger context window can be very useful. Like if I'm doing an audit, for example, auditing the financial of a company, and you have, again, hundreds of thousands of contracts and documents and procedures you have to look through while you're doing that audit. Once you find the 4 or 5 documents that you're doing the audit within, you benefit a lot by just passing the entire document to the LLM and saying, hey, go parse this now to find all of the audit problems. So there will be some use cases that will benefit a lot from that larger context window, but I still believe you need both.
Yeah, absolutely.
And
Great.
Ofer,
I think yeah, go ahead.
I was just going to say, just to add into this with some concrete evidence. I mean, we're talking about the LLM context window getting bigger, and that's a very positive thing. But let's look at what's happening in the rest of the industry. So look at vector databases closely associated with neural information retrieval. We're talking about systems like Fias pushing 1 trillion vectors in a single index, and then serving that again. So now this goes back to the point that some of the other guests were making. The attention mechanism is somewhere between n squared and n on the context length. But these systems like Fias, they're sublinear in terms of how fast they can retrieve the information, somewhere between the square root of n and the log of n. And again, now they're pushing size in the trillions of vectors. So it's just a massive difference in the amount of information these systems can process.
And that point Amin is making is very important, because there's some people that look at this and say, oh, this is just a matter of time. When the hardware improves, we'll be able to do it in the context length. But no, this relative performance between sublinear to order of n squared is always going to be there, right? That's a fact of the matter of the algorithms we have today. So even when you have faster hardware that can do the order of n squared quicker, the order sublinear will still beat it. So it will always beat it. There's no debate around that. So as the hardware speeds up, still the RAG approach will always be better performance and better cost. There's no debate around this.
Yeah, and I like, how you think about it in terms of sort of, yeah, exactly. Like it's a pipeline, and where do we as engineers sort of put our efforts and our trade-offs between, speed and efficacy. So my next question was going to be about something that all of you started already talking about, but I'm going to pose it anyway in a little bit of a different way, which is, so okay, so we think RAG is staying. That's great. But then, like was said here, there's going to be a lot more opportunity to do new things with longer sequences. So where do we see, what will be the most effective techniques? Are we going to just increase the chunk sizes or not? Are we going to include maybe whole documents like Amin said earlier? Like where do we see these different things?
Yeah, I can start here. So I think using longer context LLM with RAG, I think might benefit the whole pipeline, since you don't like with this added benefit of long context LLM, like you can put in much more documents or relevant documents into the context, and that decreases, or you don't have to think about chunking strategies or optimizing or over engineering those things. You can simply put in more information which is relevant, of course. And I'd like to share one more fact about from the study that the Nvidia research did. So they used a Llama 270B LLM with 32K context window with RAG pipeline, and then they compared it with GPT 3.5 Turbo with 16K context length. So they compared the results and found out that Llama 270B with 32K context length performed much better than the GPT 3.5 Turbo. So I think the best case here is like using long context LLM with RAG, but you also need to think about the compute cost and the latency cost. And in that regard, I think currently using LLMs with short context and with retrieval augmented generation is the best bet for now. Yeah, but we'll get there. I think Nvidia is doing great work across the stack to optimize everything. But yeah.
Yeah, so I mentioned the use case of being able to do an audit and feeding the full documents as part of doing that audit, and you can imagine that many other similar use cases like that. Another benefit is the multimodal aspect. Like sometimes the document is a video, and I want to feed in the full video, right? I found some in the retrieval stage. I found a number of relevant videos that are part of this investigation or part of answering this prompt, and I want to upload them. And that's where the bigger context window makes a huge sense, actually, because as you know, these videos can carry a lot of tokens in them. So that would be another use case which I think this would be useful for.
I think I have a question rather than an answer, which is one of the sort of open questions that I've seen people debating recently is it's around chunk size. Like we were talking previously about chunk size of 512 versus 1024 or something, but now you can have absolutely enormous chunks and it's fine. But the debate, and I genuinely have no idea what the answer is whether or not you lose retrieval accuracy by having enormous chunks. Whether or not you're properly encoding meaning if you're chunking at the scale of a document as opposed to a paragraph. And I'd love to know what my fellow panelists think about that.
Yeah, I've done some work in that area, and in the past, there is a theoretically you will lose resolution as you condense more and more information to single vector. On the other hand, 512 or 1,000 dimensional vector space is quite large, so you don't need to necessarily conflate the two. The vectors that are stored in the vector index can still be chunked at some sub-document resolution, but when you retrieve that vector, instead of just passing that chunk into the context of the LLM, you can go and fetch the corresponding document and put the whole document in. So that's then that way you kind of had the best of both worlds. You've got the more granular indexing strategy going on, and yet you're taking full advantage of the larger context size on the LLM. That's the way I've thought about it till now.
Yeah, we have a built-in in Llama Index called small to big that is exactly about that.
Oh, okay. Oh, nice.
Right. So yeah, I think that's right. I think it's the retrieval chunking, and we now use the same for chunking for matching and for LLM sending for the LLM, but you can imagine much bigger sizes there too. Yeah. Anyone else? Any thoughts about this? Hassan or Jay, about this point? Okay.
No, I was just gonna say for use cases, I think I think what Ahmad said was very true. Multimodal is gonna be really big. I think like real-time use cases, a lot of people with like wearables, with the amount of information that they're trying to process, if they're trying to process like simultaneously process video frames and audio and all this stuff, like just longer context just becomes so much more useful. And I think it'll help building these kind of applications.
Does any of you think that there's new types of applications? Like we all use RAG for, our customers use RAG for like, chat bots and question answering applications and research and all kinds of, very useful types of enterprise applications. And then are there any others that we just weren't able to implement yet, but now would become possible with these longer chunks? Or longer sequences, I'm sorry.
We have seen some examples with the video stuff. The video stuff has some really interesting applications. Like you can upload a bunch of video sequences from your security cameras, and then ask the model to find all the spots where person A passed beside person B and took something out of their pocket. And the model will do that for you. It will actually look through the videos to find the instances where that happened. Now that's a use case that would not have been possible without context windows of this size.
Yeah,
I think the long context window application that interests me most is sort of hyper competent code completion, let's call it, something where instead of just giving a function or giving a description of a function or a single page of code to the LLM and saying, please, complete this function or write this test or like add, these 10 lines, you can say, here's my entire application. Here are all of the source files for this application. Add a feature. You've got full awareness of everything that this piece of software does. So you should be able to call APIs and you should be able to, figure out what it is that you have to do to add this function and where it goes in the code base.
Yes, and these use cases actually, they justify the cost and the latency. So it's okay to wait when you're doing something like that. I don't need to get an immediate response when I'm going through all of the code base to add a feature. I don't need to get an immediate response when I'm doing an investigation around the theft through security cameras. And the value of the use case also justifies the higher costs. So it'd be okay in that case to rely on a much bigger context window. So I think it's more matched in that case versus a lot of the current RAG applications, to be honest, they don't justify that high cost. Like when you're doing an interactive AI assistant or you're doing a chatbot, the cost of the use case tends to be lower. And the expectation in such an environment is also the latency is also very lower. So that's why feeding everything into the context window becomes a mismatch. And another issue that we forgot to highlight, I apologize. One more issue we forgot to highlight is the issue of security and prompt attacks. If I'm feeding in the entire corpus set of my company into the context window, then now other folks can that maybe don't have the proper identity or role to see that data by tricking the LLM and saying things in a certain way. They might get it to reveal that information to me, even though I'm not allowed to see it. Either that, or now we'll have for every single employee, we only feed into the context window the things they're allowed to see, which means we're back to RAG now. So, so let's just do RAG instead. That's how I would look at that. Yeah. Go ahead, Jay. I'm sorry, you were about.
Yeah, no problem. Yeah, so one application that I'm personally excited about is personal AI assistants or AI chatbot. So it's mainly looking like, or to me, it looks like a Jarvis kind of feature, diamond, where each of one of us will have personal AI assistant and they will know all of our data or context. With the current AI chatbot, the problem lies in the context window. So if I'm having long chats, so for example, ChatGPT. So ChatGPT tends to forget what I had in the earlier instances of my chats. And that can be like limiting for those kind of applications. So having long context LLM with RAG, I think that might best bridge the gap and it might get us the Jarvis kind of future that we are hoping for.
Yeah, the 30,000 tokens is more than enough for that. Like, 1 million tokens is overkill for that use case. 30,000 tokens is enough for very long chats. I agree with you.
Yeah. Go ahead. Go ahead. Sorry.
Yeah, I was just gonna say really quickly. I think a nice side effect of longer context sizes is cheaper token pricing, is what I've seen generally. Like as it's gotten bigger, tokens have been cheaper. So I'm really excited about just using AI in places that we haven't thought of using it because it's way too expensive and it doesn't make any sense right now, but may make sense down the line as context window grows, but as token pricing becomes cheaper too.
Good point.
Yeah, very good point. What about, let me poke in another area for a second. What about, there's some work that's been done to take the text that you want to ingest and use longer sequences, for example, to create summaries of that and things like this, and push that as input to the RAG pipeline. Anybody bump into those techniques and have thoughts about that?
Sorry, so describe it slightly more, Ofer. What's going on
So
here?
if you have a really a book of 100 pages in a PDF, instead of ingesting the whole PDF, you ingest summaries of the book or something like that, or some variations of it, or you ask an LLM to create synthetic data to complement it. There's some stuff I've started hearing about doing techniques like this, and I find again that they're somewhat related to longer sequences if you want to do a good job with that. I'm just wondering if any of you have seen any of that or have opinions about this. Maybe too new.
I think it's still a research area.
Okay. Go ahead.
Go ahead, Amin. Sorry.
I was going to say that the idea of enhancing information retrieval quality through machine learning has been around for a while. So, for example, with keyword systems, you would often take the documents in the last, let's say, 7-8 years, and run a neural network over the document to produce additional keywords that should be indexed with the document to improve its recall. So there's one paper from Stanford University recently that kind of touches on what you're saying is I think it's called Raptor. They basically, instead of organizing a traditional vector database, instead they've got this kind of tree where you've got the leaf nodes are the smallest chunks of the document that have been vectorized, but then the parent nodes somehow like they represent larger units all the way up to the level of the entire document. So there's some work going on in that direction. I would say though that the need to, let's say, summarize and feed in summaries, it seems to me like it's more to address, if you're specifically talking about the context of like to put into the LLM context, maybe it has more to do with the limitations of the context length. So as the context length grows, the pressure and the need to do that actually goes down.
Good point.
Yeah,
I agree. Okay, so good. I think we cut.
I would say it goes down, except for the pressure goes down to do that, except for, again, if you're optimizing for something else, like if you're optimizing for performance and you want the latency to be really, really immediate, like in terms of response time, and you had a big library of books that you uploaded into the system, so like 1,000 books, and you find that you found the 2 or 3 books that are most relevant to the prompt task at hand. If you feed the entire books into the context window, then it will take longer. If you feed the cliff notes, the summary of that book into the prompt, then now you'll get an answer much quicker. It's not going to be the best answer, but it's still going to be a good answer. There's some maybe other requirements that might push you in that direction. But I agree with Amin in general, you will need that. Depends on the use case.
I think a nice thing that the longer context enables in that specific use cases, I think, is you can run the summaries and you can pass them in and you can generate a response, and then you can also in parallel pass in the whole books to another LLM call and get a more accurate result, but just show the user a very quick result there, and then maybe update it with the answer or fact check it with the other one and then update it in real time. So I'm excited for these like progressive use cases where you see something really quickly and you're still taking advantage of a small context, like low latency, but at the same time you can fact check or you can supplement it.
Good point.
All right, so what do you think is going to happen next? What's going to be the size where, you know, LLM vendors are going to stop caring about this and not like where we're going to get to 10 million? Are we going to get to 100 million? Like where's it going to go?
I think it will keep going up because there's use cases that justify it. There's some use cases where having the larger context windows makes absolute sense. So again, like the video security use case, for example, that I can see that being very applicable there. Or if you're working on a new type of movie and you want to influence the script that's coming out with previous movies that you want to feed into the system. So I can see it very beneficial. Or imagine yourself like uploading your entire data of your life in the context window while the context window is answering something for you, so that can answer it for you in a way that is culturally appropriate for you, that makes you understand it easily, etc., etc. So I believe that that will keep going up, but not every use case will take advantage of that much bigger context window. That's my belief. I could be wrong, obviously.
I think what I'm going to be interested to see is the longer context windows appearing in the open source models. At the moment, you know, the largest context window in an open source model is still quite a ways behind 1 million. We see at Llama Index tremendous interest in local models, almost out of proportion to what you can do with them. People are sort of intrinsically interested in, but what if I could do this without sending it to a service? As the trickle down of large context windows reaches the open models, it's going to be really interesting to see what people start doing with them.
Yeah, agreed. Databricks released an open source model today called DBRX. I haven't read the news yet in detail. So anybody noticed how big was the context window for that new model Databricks released? 32K, so still on the small side. Yeah, so we're all rooting for Llama 3 then. Hopefully they will give us that bigger open source context window. Because I think the 1 million token now is only Gemini 1.5 Pro and Claude 3. I think Claude 3 is also 1 million, if I recall. Claude 3, one of their, they have multi-tiers in Claude 3, but one of them has the 1 million token.
I also think that I agree with everyone that larger context length can definitely be put to good use. It's one of those things, though, like the number of parameters inside the neural network, which has become a little bit of a vanity metric. I think it basically, there's a few things that are being optimized heavily in the research community, increasing the context length, reducing how expensive attention is. So, you know, full attention is n squared. There's been a lot of work, Mamba, for example, being the most recent, which looks quite exciting, to actually reduce the computational complexity. And then the third is to improve the quality of the attention. So, Amr, you mentioned like the needle tests that they do to see how well can it actually pay attention to everything in that context. And, you know, until recently, it wasn't very good. Like around the middle of the context, it would lose track of what was in there, but pay attention to what's at the beginning and the end. I think one of the things about Gemini is that if I'm not confused, Gemini aced the needle test.
For single needle. For single needle, I mean, but not for multi-needle.
Okay, so multi-needle.
Yeah, multi-needle, they still have issues.
Right. So I think that, you know, the continued research in all three areas is actually important, not just increasing the length of the context.
Agreed.
100%.
Right. Yeah. As everyone said, like it will keep on growing, and we'll find some use cases to fit those long context LLMs. And as time progresses, like Nvidia will also keep improving in terms of like memory and cost optimization. But I think the main question here, like, do we need long context LLM like for all kinds of applications? I think it's just what problem you are trying to solve, and then decide will this be helpful, because like researchers keep coming up with like new and the best LLMs, but is it helpful for your use case? I think that's the question you should try to answer.
Great. Thank you, everybody. I think we're kind of coming at the end of the questions I had, and I wanted to leave you all an option. if you have anything else to share about this topic that I didn't ask about, it's optional. While Dina, if you're still on there, if there's any questions that we collected from the audience that the panelists can answer, we'll do that next. So if you're listening live, and you want to ask a question on the chat, you can do that now, and we'll try to take some questions from the audience. So anybody have any last kind of summary or words or things that we haven't touched on that you think our audience here would like to hear about?
Yeah, I can go first. So I think it's not either one of those. Like, should we just use long context LLM versus or RAG? I think we should use them as complementary approaches. Both like retrieval anyway boosts the performance of long like short context and long context. It's just the application that you are trying to solve for. So I think it works best for both sides of things. So that's one thing. The other thing was we just completed, or we just came out of a great conference, Nvidia GTC, that happened last week, and there was a ton of good conversations that happened around RAG from industry folks, from research folks. So I think if you are interested, the session recordings are up live on Nvidia on demand. So feel free to check them out. Those are free.
Yeah, no, I agree with Jay. It's not either or. Like this is a false discussion. It's not either or. Both approaches are relevant and useful depending on the use case. And definitely, the larger context window helps RAG become much more powerful. So, like I know we paused the session and we marketed it to create some tension between both approaches, but I think they play together very, very well. Now, the other open question I have, and I don't know if folks have seen research where this can be improved or not. We know with RAG we can easily do citations, right? So for the response, we can cite back which documents and which facts were behind every sentence we have in the response. And we can do that very easily in a RAG context. If I load my entire data set in the context window, is the LLM still able to do that? Is to provide back in the response linkages back to which documents and which pieces of information were relevant to the conclusions being made. I don't know if that's something that there is possible to do today or not. That's a question for the audience. If any of you know the answer to that, but I'd be skeptical about that as well. The explainability of the response.
Yeah, we know that for provenance is what we call it on our side is extremely important to a whole batch of use cases where people use RAG as essentially extremely competent search. The point of the query is to find the document that it came from, not to answer the query itself.
Okay, well, thank you. We have a couple of questions that I got here from the audience. So if it's okay, let's move to those. Before I go there, I just wanted to mention everybody who's listening that this event is also part of, and everybody here on the panelist is also part of our upcoming hackathon in April, organized by everybody here. Thanks to everybody here and our partner Lab. And so if you're interested in exploring RAG, exploring all the technologies, Llama Index, Together, etc. We encourage you to join the hackathon. Apply to register. It's on the Lab website. So with that, I'll go to the first question.
What are some of the prizes from the hackathon, just to excite us a bit?
Sorry?
More?
Oh, yeah. Some of the there's really, really good prizes. There's both cash prizes and there's credits provided too. So there'll be everybody will be able to use Vectara platform for their hack. There's going to be Hassan and his team Together are going to provide credits for the Together platform. But in terms of prizes, we'll have I think it's above $12,000 in combined prizes from all the partners. So and I have to look at the page, and I don't want to move from this view, but I think that's what it was, something like that. Let's see. No, I'm messing that number up. Let me look it up while I give you the question. I'll come back with the number. Anyway, but it's a big chunk of cash prizes as well as credits for different systems for everybody who participates in a hackathon to also be able to continue using this after the hackathon. So it's a very great opportunity to do that. I got the prizes here. Sorry. So we're having first prize is going to be $1,500 in cash, plus $1,500 in Vectara credits. We have $1,000 for second prize and $500 for the third prize. And we have special prizes from Llama Index, from Together.AI as well, and from Unstructured and Tonic AI, who are not part of this panel, but part of the hackathon. So very exciting technologies involved. I really highly encourage you, if you're looking to learn about RAG and try it out, then you should join that. So now to my first question. What do you think about the latest research? There's a paper, I think published actually by a team at Berkeley, called RAFT, Adapting Language Model to Domain-Specific RAG. The reason I know it was Berkeley because I happen to be right now at a conference and I met the head of that group, Joey Gonzalez. So I think his team wrote this paper. But the question is to this group, if you're familiar with that paper, what do you think about that and how it impacts RAG in general? Anybody know about this paper first? Or it's kind of new,
We actually just released an implementation of it for Llama Index earlier this week, so it's extremely convenient.
Okay, so go ahead.
I don't want to get too far out on my branch since I was not the one who implemented it. But obviously, we built it into the framework because we think it's an excellent approach. The central idea, as I understand it, is that you can fine-tune your data. You can fine-tune your model on RAG rather than instead of RAG. So you fine-tune your model with the data that you were going to look up anyway, and you get better results as a result of fine-tuning with the data that you've retrieved. Am I correctly summarizing there, Ofer?
My understanding of the paper is that it's actually a way to generate synthetic data in a very specific way, and then feed it into your augmenting your original data with this data for the fine-tuning purpose. And that, in some cases, could be beneficial in terms of overall performance. That's my understanding. So I would say, for the purpose of this panel, because we're not very familiar with this, I apologize for the person asking this question. We will take this offline and try to maybe provide a better answer. Maybe I'll try to write a blog post about it as well. And I think you could definitely look at the Llama Index implementation, and I'm sure there's a blog post as well on that coming soon. But I think it's, it seems promising, and I think we'll, as an industry and a community, I think we'll go and look at that and test it in the next, coming months and see where it plays in. Another question that came in.
My only comment on RAFT, and I think Amin, I saw him trying to answer as well, so maybe he wants to add something.
Sorry.
My only comment on RAFT is it actually requires fine-tuning the LLM with these examples. So that's one of the key steps in RAFT, is you're fine-tuning the LLM as a function of the examples with that domain and how you want the answers to look. Fine-tuning in general is expensive. It's not cheap. So you only want to do fine-tuning, again, if the use case justifies doing the fine-tuning. So my response there would be, yes, RAFT could be very useful to get you a couple of extra performance, relevance and quality of results performance. But for some use cases, that's not going to be worth it. Like, why should I go and retrain the LLM when I can? If the LLM is good enough for my domain, I don't need to do that. If it only buys me 2 percentage points and I have to go and pay this much more money and wait this longer for the training to be finished, then it might not be worth it. But for some use cases, that would be worth it. So that's kind of my high-level view on RAFT. I mean, do you have anything to add there? I saw Jay also nodding his head.
I was just going to make a meta comment. The last time we had a meetup, I think we had a question about Raptor from Stanford. I was just looking at the RAFT paper now. I had heard about it, but don't know the details yet. It was released on the 15th of March. So it just shows how red hot this field is and how quickly it's advancing. We're getting questions about papers that were released like a week and a half ago. And I think it also goes to kind of underscore, so this time around, like going from like the research to actual usage through platforms like Vectara or frameworks like Llama Index and LangChain very, very quickly. So that's exciting to me. That was the comment I wanted to make.
And Jay?
No, I think, yeah, I haven't read that paper, but I think I should read it. Seems interesting, but as Amin said, like it's growing really fast. And going from research to production or use case, I think that is interesting. And it's great to see.
Anyone else on that question? Any other thoughts? Okay. Next question was asked is, what is a language?
Well,
anybody want to take that?
One of the beauties of neural information retrieval is that language is no longer a boundary. In fact, neither is actually modality. You can switch modalities and you can definitely switch languages, and your information retrieval system will work properly. So for example, right from the get-go, when we launched Vectara, we supported 16 different languages. You can index content in 16 languages. Now that number is over 100 with the introduction of the Boomerang models last year. So regardless of what language the information is in, the retrieval step, the R in the RAG, can retrieve it, let's say on the Vectara platform, or you can do the same thing in Llama Index using a suitable dual encoder, choice of dual encoder. And then now there is a question of plumbing it through all that multilinguality through all the different pieces. So for example, whereas Boomerang supports over 100 languages for the retrieval step, a model like Mistral, I think officially supports 5 or 6 languages and maybe unofficially supports a dozen or 24 languages. So you can kind of have this impedance mismatch between different components where some components in the pipeline support a language and others don't. But in general, the trend is towards broader and broader support for all languages. And I don't think it's going to be very long before the core components of a RAG system, which is the retriever, the re-ranker, and maybe the LLM, they all can support over 100 languages, at which point you're covering basically 99.9% of the languages used in commonly for business. That's where I see things going.
Yeah, like one of the key updates we just did recently, we had released in November a open source model called the Hughes hallucination evaluation model. And that was primarily focused on assessing the factual consistency of the responses from a RAG pipeline. And it was focused just on English, the one that we released back then. And now, yesterday, actually, we just released a new one, but it's not open source yet. It's within our system that supports a lot more languages. I don't know the count, actually. I mean, how many does the new one released yesterday support?
Officially, it supports French and German as well, but we're rapidly expanding that support.
Anything else on languages? Anyone? So I have another question here. We'll move to that, and I'll read it to you. A simple question. How good are current RAG systems, and do you know any actual use cases currently in real projects? Because sometimes I feel RAG is like blockchain, a lot of hype, but no realized use cases yet.
Who's asking that question? No. There's a number of companies here all making money left and right on RAG. So I disagree with that. This is a research project or a blockchain thing. I will mention one example, and maybe the other members can mention some examples from their customers base. So I will highlight Sonosem. Sonosem is one of our customers. They are in the ultrasound space. This is a production use case. This is being used in production. So what Sonosem does is they help radiologists use ultrasound machines better. When you're configuring an ultrasound machine and calibrating it, there's so many parameters that have to be calibrated correctly. And you calibrate them differently when you're scanning for pregnancy, the heart, lungs, a muscle, depending on what you're looking for. And also you calibrate it differently based on the characteristics of the person, male, female, age group, race, etc., and the type, the model and manufacturer of the ultrasound machine itself. Only the expert radiologists know this stuff solid in their head, and they can do it. The average struggles with that all the time. So what Sonosim did is they uploaded a lot of best practices into our RAG pipeline, a lot of best practices in terms of how to configure these ultrasound machines. And now their customers using that, this is live production use case, their customers, while they're using this software, they're able to have this very smart assistant, just like ChatGPT, that helps them configure the ultrasound machines optimally. And now the average radiologist becomes an expert radiologist because they have this mega brain beside them, helping them come up with the best calibrations. That's just one example. There's many, many examples. I would like the other folks on the panel to some example.
Yeah, we have a lot of customers sorry, go ahead, Laurie.
No, you first.
We have a lot of customers that Together that do RAG and that use it in production and whose whole business is RAG. We have a customer called Rogo Data, and they built this very extensive RAG pipeline into like this financial product. And it essentially helps bankers and hedge funds and everybody look up financial information very, very fast, and it indexes like so many things, 10Ks for companies, stock market, like it has so many different things, and they're doing amazing. They just raised millions of dollars. They're signing banks and hedge funds left and right. And yeah, RAG is just a very big central part of their product. So we're definitely seeing it in production a lot.
Yeah, what I was going to say is, so we just ran a survey of our users. We know that the biggest production use cases for RAG are, at least for Llama Index, are finance, healthcare, and legal. And I could go into examples of all of those, but the one that sticks out to me is a customer of ours who are solving a problem that doctors have. Doctors, general practitioners, when they see a patient, they have on average like 15 minutes with that patient, but that patient could have a medical history that spans their entire life. So one of the things that they're using the system to do is they use an LLM to retrieve the patient's entire medical history and their current complaint, and look at, here are all of the things that are relevant in their medical history to what they are complaining about right now, which is a process that could take, even a doctor hours, and it just gets done instantly so that the doctor can then go, okay, here's the test you've already run, here's the things you've already tried, let's try this.
We're also seeing examples in manufacturing. So this is another production customer that we have. Obaikan Group is their name. They're the largest manufacturer in the Middle East. They have hundreds of thousands of workers in their factories. And sometimes the machines in the factories and the production line in the factories fail. And the workers don't know how to fix the machines. They have to call a technician. The technician can take a couple of days to show up, and the technicians are more expensive to call them in. So what they did is they uploaded all of the manuals of these machines in the production lines. They uploaded all the troubleshooting tickets for how the technicians were able to fix and fine-tune and repair these machines in the past. And now the workers in the factory, they have a mobile app that they use to just fix the machine themselves. So the average worker became a technician. And the other beautiful thing is the workers they have in their factory speak many languages. They don't just speak English or Arabic, which is the most dominant languages, but they speak many other ones. So now the worker can ask the question in any language, from Punjabi or depending on where they came from, and they get back the response correctly for repairing that machine. And while they're doing that, not only are they now able to fix the machine, which is less downtime, it is less money savings because you don't have to call the technician. The workers themselves get upskilled because now they're learning more complex topics that they were not being exposed to earlier. So it's a triple win in many ways. Yeah. So really want to stress, no, RAG is not blockchain. RAG is the real deal.
Well, thank you for those examples. This is great. I think gives our audience also a lot of confidence from real companies who are selling in the market for real use cases. I think we're a little bit over. People are okay to stay a couple more minutes. If not, we can end here and answer other questions offline as well. Are you guys all okay for another couple minutes? All right. So the last question here was. In general, LLMs are trying to be helpful, but this is not always the business objective. In other words, business objective could be increasing sales or customer LTV, but the retrieval system is usually the bottleneck. How does Vectara help with improving customer-defined metrics? And let me generalize it also to non-Vectara, generally the RAG as a discussion. So
yeah, no, I get the question. So you always have to have
okay.
good metrics aligned with the use case. You want to sell value, right? There's some metrics around the quality of the system, how much hallucinations it have, how accurate it is, how safe and secure it is. These are table stakes. But then you always, when you're selling into a given use case, like the medical use case, like the accounting use case, a financial use case, a manufacturing use case, you want to link it back to what's the business value? How much money are you saving because of this? So, for example, in the Obycan example I gave about the manufacturer that are using this within their pipeline, they quantified the downtime improvement that they got from now having the workers being able to repair the machines themselves, and how much money savings they got from not having to pay for the technicians to come into the factories. And that's quantified. That's the real business benefits that they were able to measure. In the SonoSim use case, their customers quantified the productivity of the average radiologist being able to use an ultrasound machine, and how much more productive and faster they can be right now because they have this very smart AI assistant helping them configure the machines correctly and get much better results. So yes, you always want to tie back your impact to the actual business value that you're improving on the customers. And that's not unique to RAG, by the way. Anybody doing enterprise software need to be doing that. You need to link back to the business savings and business value for your customer. And the very good sales teams, what we do is we go through that math with the customer and show it to them and prove it for them. And that's what sells them on, yeah, let's do this. Let's try this within our organization to see how much money we can save or how much more sales we can generate.
And Amr, the person who was asking about Bitcoin and that earlier said, thank you for that answer. It was really convincing me now that it's not only hype, but can you mention which language model is being used in the corresponding use case?
So we support two types of language models. We support the commercially available ones like GPT-4, but we also have a model that we are hosting ourselves that we use for inferencing. So it depends. Sometimes we use GPT-4. GPT-4 is still the best of the best right now, in my opinion. And then sometimes the hosted model, which is based on open source, is what we use. And in open source, I would say the best of the best right now. It depends. It depends on the trade-off between performance and speed and cost, right? A nice sweet spot we're finding is around Mistral 7B, and correct me here, Amin. So that seems to be hitting a very, very nice sweet spot. But of course, the most powerful one right now is Llama 70B, and we're looking forward to the new Llama 2 when it comes out. Llama 3, sorry, when it comes out.
Llama 3, yeah.
The Databricks one apparently is better than Llama and Mixtral. Apparently, it's the most powerful open source one. I haven't looked into it that much.
But the question is going to be how expensive and how slow it is to run, right? So you always want to look at these three dimensions together. Yeah.
It's 130 billion parameters, so you can't exactly run it on your laptop.
Yes.
Exactly. So it's going to be expensive to run. It's going to be very expensive to run. Yeah. It's going to be slow and expensive.
Yeah, I agree with Mistral 7B hitting the sweet spot. We've seen a lot of our customers kind of go with that too.
All right. Well, with that, I really want to thank all of you very, very much. This was an exciting discussion. Thank you for all your great answers. I'm sure our audience got a lot from it. And I think if I can summarize, right, RAG is not going away very consistently across all of our panelists here. In fact, it's going to improve in a lot of different ways. Some of them we know, some of them we're going to see in the next coming. I want to say coming years, but it's probably going to be coming weeks and months because this industry is moving so fast. But I'm personally looking forward to see how RAG becomes much, much better through these techniques. And again, for those who are interested, we're going to also have this recorded video later on to view. And if you have any questions to any of us on the panel, feel free to reach out after this event. And thank you all for participating.
Remind them of the hackathon again, just one last time. Sometimes people just listen to the last minute of the recording. So
hackathon, go to Lab.ai and look at the advanced RAG hackathon, which I think is the first hackathon in the list there. It's coming up in April 12 to 19. Is going to be a week-long virtual online hackathon worldwide with participation from, as I said, Llama Index, Together.AI, We're going to have also Nvidia supporting with judging and other activities. We're going to have, of course, Vectara. We are the main organizers of this hackathon. We'll provide a lot of resources, provide a lot of support with tools. We're going to have also 2 other companies there, Unstructured IO and Tonic. And it'll be really fun, a lot of really interesting projects I can see coming out of it. And I'll be there all week to answer any questions for hackers if you have any on Discord. So feel free to reach out to me during the hackathon as well. And yeah, thanks very much. Thank you all panelists for your time today. And we'll see you in the next event.
Thank you.
you.